In this video, I'm going to talk about current. Current is nothing but flow of electrons. Okay, we can say flow of charge, but in this case, charge. Mostly we have protons and electrons. Protons have positive charge and electrons have negative charge. Protons are inside the nucleus; they cannot move. Only electrons are going to move. So current is nothing but flow of electrons. Okay, so basically if you take a conductor, current carrying conductor, you stand at one point and see how many electrons. So assume that these are the buckets of electrons. How many electrons are passing this point in 1 second? That will give you current. So current is nothing but I is nothing but Q over T. Now, if it is AC current, as I mentioned, there are two types of currents. One is DC current, another one is AC current. DC we always indicate with capital letter. AC we always indicate with small letter, I of t, because it's a time dependent quantity. So DC is direct current. Magnitude does not change with respect to time. AC always changes with respect to time. So I of t equal to dq over dt. This is the formula we're going to use a lot. So if you want to find the charge Q equal to integral of it dt. Okay, now, so as I mentioned, DC current and AC current. So if you look at here, this is the DC current. Okay, so with respect to time, magnitude does not change. Current magnitude is same. Here is AC current. This is a triangle. Okay, it's a square and sinusoidal. Whatever the current coming out of your power outlet is the sinusoidal. Why is the sinusoidal? Because natural form, when a rotor rotates inside a generator, it always generates a sinusoidal waveform. So we use the sinusoidal waveform. But the most efficient one is square waveform. Okay, now another important point, the current is a vector quantity. Okay, vector means it has both magnitude and direction. So here the current, so you have to indicate whenever a current is passing through the wire, we have to indicate which direction that current is flowing. Here a 2 ampere current is flowing from A to B, IAB equal to 2 ampere. Now what we can do, we can change the current direction and say a IAB negative 2 amperes is flowing in the opposite direction. As I mentioned, it's a vector quantity. So since it's a vector quantity, we can change the direction. When we change the direction, make sure you change the sign of the magnitude. Now here is another example. Okay, here is an example. Calculate the total charge transferred and the value of I average over 0 to 15 seconds time period when I of t equal to 0.3 t ampere. So we know that the current I of t equal to dq over dt. I of t equal to dq over dt. So the question is asking about how much charge is transferred in 15 seconds. So q equal to integral of it dt from 0 to t. So here he gave us the upper limit and lower limit. So lower limit is 0, upper limit is 15, and I of t is 0.3 t. So if you integrate this, solve this, so integration of 0.3 t is nothing but 0.3 t square over 2. Okay, and substitute upper limit minus lower limit, we end up with 33.75 coulombs. So in 15 seconds, it transferred the total charge of 33.75 coulombs. Here he's also asking for I average. I average is nothing but total charge transferred divided by total time. So 33.75 divided by 15, 2.25 ampere. So you can clearly see 1 ampere equal to 1 coulomb per second. Okay. Here is the next example. Find how much charge is transferred in the interval of 0 to 12 seconds if the system is connected to 120 volt, and find I average for one complete cycle. X-axis indicates the time in seconds, y-axis indicates the current in amperes. So basically he's talking about this diagram. So this is the current and here is the time. So according to the current, the equation for the current, I of t equal to dq over dt. So q equal to integral of it dt from 0 to t. Okay, so the current is, the total charge must be area under this curve will give you the total charge. Okay, since this is negative, that's going to be negative charge. This is positive charge. So you can find that. But if you use the integration, okay, so you have to divide time intervals. So 0 to 2, the current magnitude is 2 amperes, and 2 to 4 magnitude is 4 amperes, 4 to 6 minus 2 ampere, and 6 to 8 minus 4 ampere, and 8 to 10 2 amperes, and 10 to 12 4 amperes. Okay, if you substitute, integrate it and everything, you'll end up with Q equal to 12 coulombs, and the average current I equal to 12 by 12, which is 12 coulombs divided by 12 seconds. Okay, so this is 12 coulomb over 12 seconds. That is 1 ampere. That's the average current. So sometimes you might have a graph, something like this. So basically you need to find slope of this curve. Okay, say it is some constant. So I of t equal to some constant, something like this, 2t, 3t. You need to find that 2 or 3 is the slope of that line. That is from 0 to some t seconds, 0 to 2 seconds. And from I of t is going to be negative 2t because it's going to be negative slope from t to 2t. This is another example I'm talking about. I think in the homework I asked you a similar question. So there you might need to find the slope and then find I of t. Once you know, you can find area under, you can find the charge transferred during this time period. Okay, or another way of doing it is find the area under this curve. You will be able to find the total charge. Now I'm going to talk about voltage. Voltage is nothing but potential difference, also called electromotive force. The only, I already discussed that in the previous video or one of the previous videos. So the only important thing I want to tell you, voltage is always between 2 points. Okay, you cannot say I have a voltage at point A at 10 volt. This indicates that the voltage at point A is 10 volts with respect to ground. Okay, and ground we always call that as neutral, so VAN equal to 10 volts. Now whenever you see VAN, it's VA minus VN, okay, equal to 10 volts. We know that, as I mentioned, VN equal to 0. Neutral voltage, we always take that as 0. So basically VA equal to 10 volts. So in this example, he's asking about find the VAB. Okay, he gave you voltage at this point. Voltage at A, VA is given, which is negative 10 volt, and VB is given, VB equal to 5 volts. So VAB is nothing but VA minus VB. So the voltage at A with respect to ground is minus 10 volts. Voltage at B with respect to ground is 5 volt. So VAB is nothing but minus 10 minus of positive 5 volts. So the total difference is negative 15 volts. VAB is nothing but VA minus VB. We're going to use this technique a lot, so you need to understand this. Whenever you see voltage VAB, it is always VA minus VB. Okay, I'll stop this video here. In the next video, I'm going to talk about power. Thank you.